Let us have a look at the parabola, and we are looking at the factorized form of the function. F of x is equal to a in brackets x minus x1 multiplied by x minus x2. So in this case, the equation of the parabola is given in factorized form. This is the third form, and we want to investigate the relationship between the x-intercepts and the turning point. So if you get an equation that looks like that, what is the quickest way of determining the turning point? Let's look at an example. F of x is equal to 2 multiplied by x plus 1 multiplied by x minus 1. We want to sketch that graph there, so the steps that you would actually need to take would be for you to work out the x-intercepts. And remember, for the x-intercepts, you put y is equal to 0, which is why I've got x plus 1 is equal to 0, which will give us x is equal to negative 1, or x minus 1 is equal to 0, which will give us x is equal to 1. So those are the x-intercepts. So we know that when we draw this graph, the graph will cut the x-axis at x is equal to negative 1, as well as at x is equal to 1. The shape of the graph will be the happy face because the coefficient 2 there is positive. That is the graph there. I drew it earlier on. If you look at the graph, you will notice that the turning point of that graph is at 0 minus 2. So the turning point is given from that graph as 0 and negative 2. Now I want us to look at how we can get that answer from the function that is given there. How do we make use, especially of these two x-intercepts, to work out the turning point? So we've got a negative 1 here, and we've got a 1 there, and our turning point is there at 0, negative 2. The x-coordinate in particular is equal to 0. The question is, how do we get it given a minus 1 and a 1? That is one thing you would want to investigate there. If you look at it carefully, to get that 0 there, we need to take the two values, the minus 1 and the 1, add them up together, and divide the answer by 2. You will notice that pattern from the next example as well. So to get the x-coordinate of the turning point, all you need to do is take your x-intercepts. So you work out your x-intercepts. The first one is negative 1, and the second one is 1. Add them up together and divide that answer by 2. That will give you the x-coordinate, which is why we've got a 0. Now, if x is equal to 0, you can find y by substituting x equal to 0 into the given function, and that should give you y is equal to minus 2. Right, so that is how we can make use of the factorized form of the parabola to determine the turning point. The rest is still the same. You need to work out the intercepts, like the y-intercept, which happens in this case to be the turning point. So to draw a parabola, remember you need the shape of the parabola, the turning point of the parabola, and the intercepts. So with all those, you are then free to draw the graph. Look at this example here just to consolidate the discovery that we just made. In this case, we are given f of x is equal to negative in brackets x minus 2 multiplied by x minus 4. First of all, the negative that you see there is followed by a 1. So that is a negative 1 if you want. All right. I want us to start by looking for the x-intercepts. So if you put f of x is equal to 0, you will get x minus 2 is equal to 0, or x minus 4 is equal to 0, which will give us x is equal to 2 or x is equal to 4. And that is what we get from that graph that I drew earlier on. So there is an intercept at x is equal to 2, that is our 2 there, and there is another intercept at x is equal to 4. But what I want us to look at now is the connection between the x-intercepts and the turning point. Earlier on we said we need to take the two x-intercepts, add them up together, and divide the answer by 2. Let's do that and see what we get. If you take 2 and you add 4 and divide the answer by 2, that will give us x is equal to 3, which means the x-coordinate of the turning point is equal to 3. And that is exactly what we have there. That's what we have there. And now if you know x, you can substitute into the function, and that will give you y. In this case, your y will be equal to 1. And then you do the rest, like work out your other intercepts, like the y-intercept, and remember the shape of the graph. And then you can just draw the graph and state the range if they want the range, and so on. I hope it is clear. So to summarize, if you are given a quadratic function and the equation of the function is given in that form, for you to sketch that graph, you will need to know the turning point. And to get the turning point, using the factorized form of the quadratic equation or the quadratic function, just take your intercepts. If you solve that equation there, if you put everything there equal to 0, then obviously a is a number. So if you divide 0 by a number, you get a 0. That is why I'm just going to focus on x minus x1. So that means x minus x1 will be equal to 0. In this question, x1 is the first x-intercept and x2 is the second x-intercept. So x minus x1 is equal to 0, which gives us x is equal to x1. So this graph will cut the x-axis at x1. The other point will be given by x minus x2 is equal to 0, which will give us x is equal to x2. So again, in this case, the second x-intercept is given by x2. So suppose, for instance, that a is positive. If a is positive, it means your graph looks like this. That is your x-axis there. Your x-intercept at one point is x1. The other point has an x-intercept of x2. And you are interested in knowing the turning point. So to get the turning point, all you need to do is take x1 and add x2, divide that answer by 2. That will give you the x-coordinate. You can then work out the y-coordinate as soon as you get your x-coordinate. Take note also, the x-coordinate at the turning point will give you the axis of symmetry. So the axis of symmetry is given by x equals x1 plus x2, all divided by 2. The same thing happens if the graph is concave downward. In other words, if a is negative and you are given that the graph crosses the x-axis at x1 and at x2, you can use those 2 points, x1 and x2, and work out the turning point. x1 plus x2 divided by 2 will give you the x-coordinate of the turning point. And that will also give you the same thing as the axis of symmetry.